Because it's not a
All right, so
stuff should be right.
remember, if you needed to, I need everybody with me. If you needed to, you could have changed this into the square root of 4 times the square root of -1, correct?
Mm-hmm.
A squared of 4 is
2.
2 squared of -1, I. What did we get for the second one? Negative 6i, because the square root of -36 is 6i, and you need to bring that negative sign down as well. Okay. Third one, obviously the most difficult. You could, just because you had to break down 54, right?
Mm-hmm.
Is the only thing that should have made this a lot more difficult. Square root of 54, what comes out of it?
9 and square root of 6.
The square root of 6 and the square root of 9.
Yeah.
Square root of 9, square root of 6, square root of 9 is
3.
3. So this, with the negative sign, is what?
3i.
3i square root of 6.
Times 2.
All of that times 2.
Oh.
So 2 times 3 is 6i. Square roots of
12.
6. Do not, and that might be something you weren't sure on. Do not multiply something that is not under a radical with something that is under a radical. Okay? Because that 3 is already being multiplied to the square root of 6. So if you take the 2 times both of them, you're doing it twice. You don't do that. You don't want that.
Why does the I not go in with that?
Yeah.
Because the square root of -1 is equal to I. The radical's gone. Right here. This is this. This is this.
Okay, but then in this one.
Same thing. This is like square root of 54 times the square root of -1. This is I, but it's not inside a radical anymore because I already square rooted it. The square root of -1 is equal to I, just like the square root of 4 is equal to 2, not the square root of 2.
Question.
Okay.
So the I is never going to be in the square root.
I will never be under the radical. No.
Okay.
Yet.
Yeah.
Okay, don't say that. Don't say that.
It doesn't make it any harder. I'll say whatever I want to say.
Uses my head.
Okay, this doesn't have.
Okay, so next thing. That allows us to.
Can I take a pic of this?
A pick of what?
Of the screen? Because I'm really confused.
Write it down.
Hey,
the
send it to the
If there-
algebraic.
Abby, if there's a negative inside of the square root,
Yeah, if there's a negative inside the square root,
Yeah, I get that.
Well,
But
then what don't
why doesn't it go on?
why doesn't 2 go under a square root when I ask you to square root 4? Because you already used the square root, right?
Yeah, but the I is in the square.
No, it's
You know
not.
what I'm
You take
saying?
it
No, it's
out.
not. No, I disagree with you.
I don't know.
I'm not gonna say I know what you're saying. This is equal to the square root of 9 times the square root of -1,
Yeah, but
right?
I'm talking about when there's something on the outside, like multiplied to the, so if you put a 3 on the outside of that.
Sure.
Okay.
Okay, you with me?
Yeah.
Yeah.
This is still equal to 3
Okay.
times
3
3 times
I
I. 3 times 3 is
9. Okay, but when you get something that's still in a square root.
Yeah, do something with the. Do like 35. Or 7.
We don't have that.
35 doesn't work.
25.
25.
25 square.
25 is the square root. Perfect.
9 and 2.
3 is still 3.
Okay.
Yeah. when I break this down, it's 9 and 2, which gives me 3 square roots of 2.
Okay.
Wait, can you write it? Thank you.
Okay.
Yep, got
Right?
it.
So I have 3 times the square root of 2 times I.
So 9,
Notice, not in the radical.
Okay.
So I multiply
Okay.
everything not in the radical together. 3 times 3 is 9.
Okay.
Times I is 5. Times the square root of 2.
That's what I needed.
I have a question.
2 thumbs up?
2 thumbs
Okay.
up.
Is I only ever negative, like -1? Or whatever?
I is only the square root of -1. Yes. Anytime you have a negative under a radical, under a square root, you need I to get it out. Okay? Alright, so we're past example 1 now. Okay, the next thing we need to make sure we talk about, standard form of a complex number. A plus B I, standard form. A is your real part because there's no I with it. Okay, so that's your real number. So B must be your imaginary part because it has an I with it. Okay. Biggest thing with this is just understanding. It's just like if you were writing something with a square root. Okay, we've learned this. You know not to do the square root of 2, 3, saying that's 3 square roots of 2, right? You know not to do that.
Yeah.
Correct? Right? That makes no sense. Like I'm getting looks like you're an idiot.
Yeah.
Okay? Yeah, you know not to do that. It makes just as little sense to do this as it does to do what I just showed you. Okay? You don't understand why yet. We haven't got into them, but it does. That's just as silly as the last thing I wrote. Okay? It's not standard form. You always need to write the I last. This is a complex number. Okay? Our real part always goes first. Your imaginary part always goes second. It would be like me telling you, okay, write 2x for me. And you go like this. Right?
Yeah.
Doesn't make any sense. It's not the right form. It's not the standard form of writing a number with a variable. Okay, same thing here. Real part first, and then the imaginary part. Okay? So we're good there? Because the next thing has really nothing to do with standard form. So we're good?
Yeah.
Okay. They just want to make sure you can write things in standard form for when you answer the questions. Now, the next thing they're going to do is they're going to take two complex numbers, 5x minus 20i, equal to 35 plus yi. And they want you to solve this equation for x and y. Anybody see a problem?
Y is
I is with like
says-
two separate things.
Y is big imaginary.
Okay, y is imaginary. That's actually not a problem. It's just different from what you've seen. I'm trying to solve for how many variables? Two. Well, yes, it's a variable, but it's also just a number, right? Because it's square root of -1. But I'm trying to solve for x and y right now. Is that a problem if I only have one equation?
Yeah.
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 Yes, Damien?
Can't you isolate x and plug it back into the
No, you need two equations to do that. Otherwise, you're just going to get 0. If you want to solve for x and y, you need two equations. Just like if I told you this, and I said solve for x and y. You can't solve for x and y there, because you only have one equation. Now, if I gave you two of them, now you can, oh, that's y, so let's plug that in. We get x and plug it back in, right? That's what Damien's talking about. But you need two equations to do it. Okay? Here, with complex numbers, you only need one equation. Okay? But we're going to turn that one equation into two.
Okay.
Okay? So we are going to take, because to be a complex number, you, like I said, you have your real part and you have your imaginary part, right? Real, imaginary.
Wait.
That real part, yes.
Why can it be your real minus your imaginary? Is that a thing?
It's just plus and negative,
Okay. We're good.
right? It's plus negative 20i.
Mm-hmm.
Okay? Can something that's real be the same as something that's imaginary?
No.
No. So you need to take your real part. You know that 5x has to be equivalent to 35 because it can't be equivalent to yi because that's imaginary. Okay, so we're going to take our two real parts and say 5x must equal 35. If I want these two things to be exactly equal, that has to be true. So my real parts are equal to each other, which means my imaginary parts must also be equal to each other. So I have negative 20i equals yi. Because if I want these two things to be perfectly equal, the real parts have to be the same and the imaginary parts have to be the same. So here, x equals
7.
Okay, this trips a few people up, but what do I have to divide by? I. Divide by I, they cancel. Divide by I, they cancel. Negative 20 equals y.
That actually wasn't that hard.
No, it's not
That kinda
hard.
makes
It's
sense.
just it just looks so much different from what you're used to seeing.
That makes sense.
I don't think anything we do today you're gonna think is very difficult. It's just new. Okay. I don't know that they ever will, but just be aware if they happen to do this to you, just know even though this is not in standard form, you still cannot take this imaginary and set it equal to this real.
Okay.
Why
Okay.
would they write it like that if it's
I'm
like,
trying to trick you.
I don't know if they're going to or not. I'm not for sure.
well, like in a book they don't put x2, you know, like it's not standard form, so why would they?
Well, sometimes they do. Sometimes when they give us a quadratic, some of those factoring ones, they give you something like this. They wrote them backwards on you.
Oh yeah, they
Yeah,
just
that-
rearrange them.
You just
Yeah,
need to
they do
rearrange
that.
it and put it in standard form. You can do the same thing here if you want to. Just make sure if it's got an I, you're setting it equal to something else with an I.
Okay.
Okay? Okay. All right. Taking a look, adding and subtracting complex numbers. Again, this is a concept that if I put x's in here instead of i's, you probably think it was fairly easy. Okay, but I have 13 plus 4i minus 8 plus 4i. No. But treat them like variables. Like we said earlier, they are variables. Okay? They just happen to be equal to the square root of negative 1. Okay? But you don't treat them any differently than you would an x. Yes, baby.
Why didn't it parentheses?
They put it in parentheses mostly because of the minus. That's one reason. Second reason, this is technically one thing. This is your complex number.
Oh.
Okay,
that
but I
makes
want to
sense,
add this
yeah.
with this.
Yeah,
Okay.
that makes sense.
Now, you still have to be careful. You cannot combine real with imaginary, right? Yes.
Can you just do 13 minus 8?
Yes. So 13
Nice.
minus 8 is 5. Good back there? And then what?
4 minus
4 minus 4 is
Just cancel it
I.
out.
0.
4.
Okay, just like 2x minus 2x is 0.
That makes sense.
Okay?
Does make sense.
So, you can either subtract that way, okay, or I recommended to 4th period that if I were doing this, I would change that to plus and switch all my signs in here, and I'll show you why in a minute. You're going to get the same thing, right? It's still 13 plus a negative 8 is 5. 4 plus a negative 4 is 0. You still get the same answer. Yes.
Is it always going to be matching imaginary numbers?
No.
No.
Shucks. Okay.
No.
There's always a catch.
Okay. I would recommend you distribute your negative and change it to addition, and I'll show you why on the next problem. Okay, but you just got to be careful with these. Okay, your reals go with your reals, your imaginary goes with your imaginary. Okay, so an example in showing you why I would distribute that negative all the time. 16 minus 13 plus 6i plus 8i. Okay, I'm going to show you the common mistake first, and then we'll distribute the negative and go back and solve it again. Okay, so 16 minus 13? 3. 6 plus 8?
14.
That's the common mistake that I just did right there. What did I miss?
You have to distribute the negative.
See, that negative still has to go over here. But they don't see any imaginary on the left side, so they're not saying this minus 6i, so they just forget about that negative. Okay, that's the most common mistake. So what I would recommend you doing, like I said, anytime I see a minus and then parentheses, I'm changing it to a plus and changing all the signs inside. Because then 16 plus a negative 13 is still 3, but now I actually have negative 6 plus 8, which is 2, not 14. Okay? Like I said, if you know that negative's out there and you can do it the other way, I don't care how you do it. Okay? But I know for a fact if you distribute that negative, you're going to be 95% more likely to get it right. Okay? You won't miss it then. I think you guys' skills are good enough. You will not miss it if you do that. Yes.
Where'd you get the 3 from?
16 plus a negative 13.
Okay.
16 minus 13? 3.
And where'd you get the 2i from?
Negative 6i plus 8i.
Okay. I think I'm just going to try to see sentences.
Just do it.
We're trying to put this on the first.
Yeah, if you distribute that negative, you can just get rid of the parentheses if you want to.
Okay. Yep, I like that.
Okay? But if you do not distribute the negative, and you just drop the parentheses, now I guarantee you miss it.
Okay.
Because that negative belongs to that 6i and you
Yeah.
can't see it anymore. Does that make
Okay.
sense? Don't drop the parentheses unless you distribute your negative sign.
Can you do it without distributing it real quick?
You'd be wrong if you didn't.
Well, you can do it, you just got to be super careful. 16 minus 13 is 3. Take the negative. Negative 6 plus 8 is 2i. You can still do it, but as soon as you get going a little bit too fast and you miss that, it's wrong.
Okay.
You know what I mean? I would distribute the negative every time, and that's why.
Sounds good.
I still do to this day. I don't take the shortcut.
And so if it was plus, then you just...
Yeah, if it's plus, it's easy. That's why I didn't do any of those. If it's
Okay.
plus, you just go through and use all your signs.
Okay.
You don't have to distribute a positive sign.
Then it would be like 14i?
Well, yeah, but it'd be also be 29.
Yeah, yeah.
But yeah.
Okay, this makes sense.
Okay.
This makes sense.
All right, last thing I want to look at, example 4. Okay, it looks really long. Basically, what we're doing is finding impedance of a circuit. And we can go through and read here. Okay, electrical circuit components such as resistors, inductors, capacitors all oppose the flow of current. This opposition is called resistance for resistors and reactance for inductors and capacitors. Each of these quantities is measured in ohms. The symbol used for ohms is the uppercase Greek letter omega. Okay, basically what you need to notice is the chart. Okay, the question is asking us for the total impedance. Okay, if you look at that chart, notice the bottom row says impedance, right, in ohms. Is everybody with me?
Yeah.
If you're not looking at the chart, you're going to have absolutely
Okay.
no clue what I'm talking about.
Okay.
107.
Thank you.
down. Why? Okay, does everybody see on the bottom row is impedance? Okay, now so where it says impedance under the resistor, that is only the impedance for the resistor. Where it says, where you follow down inductor to impedance, that is only the impedance for the inductor. Where you go to the capacitor and all the way down to the bottom right, that is only the impedance for the capacitor. We want to know what is the impedance for the whole circuit. Okay, so what do you suppose we're going to have to do with those? We're going to have to add them together. Okay, so I'm going to draw a little bit different diagram than what they have. That way we have to do our own problem. This one's 8 ohms. That's supposed to be a Greek letter omega. Go with it. This one is 10 ohms. And this one is 12 ohms. We haven't even done anything. What's so confusing?
I don't understand what ohms are.
It's just a different measurement.
What's impedance?
It's like electricity, isn't it?
It's like that with electricity.
Just worry about the numbers.
Okay.
Don't worry about the ohms.
Ohms is a way to measure electrical current.
What are
It's like feet.
symbols on the circuit? What is?
They're
Those are
ohms.
ohms.
No.
Oh, the marks?
Yeah.
They correspond with your chart. Resistor,
Okay.
resistor, inductor, capacitor.
Okay, makes sense.
And so
Okay.
the omega is for ohms.
The omega stands for ohms, yes.
Okay.
Okay? So, we just want to find the total impedance. Well, the impedance for the resistor, R, which in our case is 8 ohms, is just R. So I just need to take 8. But as you look at the chart, the impedance for the inductor is your inductor number times I. Okay, your inductor in this case is 10, so I need to add 10I. When you go to the capacitor, it's negative CI. Well, in ours, C is 12, so I need to add negative 12I.
Oh.
Okay?
Do you have that? Have the premises?
No. I just added, so I put them. If I'd have just put minus 12I, you'd be fine. Then all you gotta do is add them together.
Mm-hmm.
Okay, well we've done this. Is there anything to add with 8?
No.
No, so I have 8 plus negative 2I or minus 2I, whichever one you want. Is there a label on this?
Yeah.
Yeah, it's
It's ohms.
That makes sense.
Okay. You're finding a total. And they give you a chart telling you the impedance for the resistor, inductor, and the capacitor. They want the total impedance, so you got to add the 3 together. Okay. Questions?
I do have a question.
Go ahead.
Will it tell us every time what like the resistor, inductor, and capacitor like are? You know what I'm saying?
What the impedances are,
Yeah.
or what the numbers are?
No.
The symbol?
They-
Yeah, like both. Will it give us the
They'll
exact
give you.
same?
They'll give you this. You'll use the same chart we just used.
Okay. So
That-
we need to like
that-
memorize that chart.
No.
Okay.
Are they gonna have a lot
Be
of
in your
problems
homework.
like this?
They're giving you that so you
Okay.
can do
So
it.
it all okay.
They will either give you the chart, or it'll be in your examples, like for your homework. On
Okay.
tests, they give you the chart.
Okay.
Okay.
So is this every word problem in this lesson? Dang it.
No.
Man.
Okay.
Wow, this is a really big lesson.
Yes, really big lesson.
How
That's
many
why
is
we're
that?
doing half today and half